So continuing with dehydration of alcohols, I will tell you what happens in step 2 and step 3. See, in step 1 what was happening is formation of protonated alcohol. Step 1 in dehydration of alcohol was formation of protonated alcohol. See, this was alcohol. You will get this CH2 OH. H plus attaches to this oxygen through a coordinate bond. You get this. Now, in the step 2, removal of water occurs. Removal of water. Step 2 is removal of water. Removal of water. CH3, CH2. See, now plus oxygen is not stable at all. So what this will do is this will break this bond like this. So this will get minus plus will be neutralized. So water is removed and the carbon behind gets a positive charge. So you get the carbocation like this, CH3CH2 plus. Now if there is possibility of formation of more stable carbocation, then carbocation rearrangement can occur over here. So carbocation rearrangement is a possibility over here if more stable carbocation can form. So carbocation rearrangement can occur and more stable carbocation will be formed. And what are the types of carbocation arrangement? Hydride shift, methyl shift, ring expansion, ring contraction. These are types of carbocation rearrangement. So any of these types can be present in a given carbocation depending on the situation. Alright. So hydride shift can occur, methyl shift can occur, ring expansion can occur or ring contraction, whichever makes the carbocation more stable will be happening over there. Then we get the most stable carbocation and from there adjacent carbon gives out H plus and we get a double bond. Here there is no requirement of carbocation rearrangement. So in the step 3 we have deprotonation. We have deprotonation and we get alkene. See, we have a carbocation like this. Now this carbon has a hydrogen. Now you have HSO4 minus, which was the base in the beginning. This comes and takes back H plus. So H plus is gone. Now this carbon gets a minus and minus and plus gives you alkene. So alkene is ultimately formed by acidic dehydration of alcohols. Alright. So more the alpha hydrogens, more the resonance, more the aromatic character, more will be stability of alkenes. Now rearrangement reactions, I have already discussed hydride shift, methyl shift. These things can happen to increase the stability of a carbocation. So if I tell you what is happening here, if a carbocation is forming like this. Now this one has two alpha hydrogens. This alpha hydrogens are present on alpha carbon, two alpha hydrogens. Now you will see whether a more stable carbocation can form. So the answer is yes, more stable carbocation can form. So hydride shift can happen over here. Hydride shift will happen and H minus from this carbon has two hydrogens. So one hydrogen will be broken as H minus and this will go and bind to this carbon. So if this hydrogen is broken as minus, this carbon will get plus. So after bond cleavage this carbon gets plus and this H minus shifts to this carbon and we get a more stable carbocation like this. This is known as hydride shift. Shifting of hydrogen from the adjacent atom in form of H minus. Now why this shifting occurs, you get the answer over here. See, it has 2 alpha hydrogens but it has 6 alpha hydrogens. So more stable carbocation is formed by hydride shift. So rearrangements happen to increase the stability of carbocation. Alright, next we have a polymerization reactions, which is nothing but combination of units of a alkene. If we take ethene we get polyethene. If we take propene, we get polypropene. If we take styrene, we get polystyrene. Styrene. Pi bond is opened up and multiple units of the same molecule attach to each other to form a long linear chain, which is known as a polymer. Alright, so polymer are used so many places in day to day life. You might have taken a polythene bag whenever you go for shopping. You might have seen a bucket which is also made up of polymer. We have um, bottles made up of plastic. So plastics or polythene bags, everything is polymer. So polymerization is a phenomenon to formation of polymers. Alright. Next is pericyclic reaction. Such kind of reactions, we do not have intermediates such as free radical carbocation, carbanion formation. Only concerted mechanism happens. Example, if we have CH2 double bond CH2 and we have another CH2 double bond CH2, there is no requirement of catalyst or any special reagent, and the reaction happens automatically. See, this bond will break and this bond will break like this. Here minus plus, you will get plus minus. They attach to each other forming a ring without any intermediate, without anything else. A ring is formed in a single step. Such kinds of reactions are known as pericyclic reactions. So pericyclic reactions are concerted mechanism, one step reactions without any intermediate. So that's it for now. Thank you.